Happy prototyping, everyone! Welcome to the next video in our Do-It-Yourself Smart Home series. In this video, we want to talk about the PCB design. First, pin mapping. As I told before in some videos, in the video we choose the microcontroller, I was thinking like the ESP32 has enough resources. It turns out that some ports are already taken for the flash and the PS RAM. So yeah, we actually run in resource problems. So we also need our SPI to UART bridge also in the room sensor. So I have not enough I/O ports to actually use the UART built into the ESP32. This is the final pin mapping for the PCB design I did. And this can maybe change in the future if we need to change something. Then we have the libraries. Like each device we want to use, we actually have to find or to build a library so that we have the symbol in the schematic and also the device for the PCB. I put mine on GitHub, so a lot of them are copied from Snap EDA, so there will be a license here, and yeah, you can look at that. Next, we will look at the schematic and the PCB layout. First, we have the room, and the room, this is the PCB what is used in every room for controlling and for sensor data. And this actually, I decided to use two PCBs. One will be the cover, and the other PCB will be connected through a pin header, and there will be the 230 volt switching. So a quick overview, we have the power supply, so it's converting our boost voltage to the 3.3 volt and also some additional voltages for the camera. Then we have our fixed address. This will be entered with a dip switch, and we have an oscillator. In other projects, like I saw with cameras, for example, the clock will be generated from the ESP32, but in our case we don't have enough I/O ports to do that, so we will just use a crystal oscillator. Then we have the ESP32 itself, then the camera is connected, we need some pull-ups for the E2C lines, and we also have the boot and the reset. Then we have the SPI to UART bridge. Here we have the RS485 converters, and we also have some protection circuit for protect against high voltages. And then we have the audio codec and our sensors, the light sensor, the gas sensor, the humidity pressure sensor, and our movement sensor. This is how the PCB looks. This is the top view. Everything is mounted on the top, and also only the sensors are mounted on the bottom. So the bottom will be what is visible, and yeah, this is how it looks. Then we have the interface board. So here are the two connectors where the interface board is connected, and this is the schematic of the interface board. We have the connectors, we have the terminals for the mains, and the terminals for the network. Then we have solid state relays, and they also have over voltage protection if they're in the off state and there's a power surge. This will protect them, and we have also a fuse in case like we have a short in the load. And then we have the optocouplers. This is to detecting the input if a switch is pressed. And we have also a circuit to smooth it, so like it will just mains is present, it will be on, and if not, it will be off. If we don't do that, like we will have a 50 Hertz change in signal if main voltage is detected. This is how the PCB looks from the top view, and here we have isolation gaps, so that the mains power is good isolated from like low voltage part. And here, for example, the distance, it was too small, so I added some milling that like we have an air distance here, and it's not so bad that the distance is not high enough. Then we have our main node. This is a header for the Raspberry Pi. So we have a component which have the pin header for the Raspberry Pi. Then we have also our power supply, which converts our boost voltage to 5 volt to supply the Raspberry Pi. And then we also have our SPI to UART bridge. And this is how the PCB looks like. We have the chip, we have the converter for our RS485, and here's the power supply. Then to the part list on the GitHub, there I have put part list. Like if you want to build it yourself, you have, for example, to look up the resistors. Depends on the supplier, so I did not go into that. For more complex part, I actually have some part numbers, but you can choose any part you like, which respect these properties here. And some prices, but yeah, should be not too bad. And also the part list. Also this was the part list for the master node, and this is the part list for the room nodes. So to the next steps. Next up, we have to order the parts, order the PCB, and to start building them and to start testing them. So we'll see if the layout has errors, if you have to change something, if you have maybe to respin it, if there are some problems elsewhere. So this will take some time, and so I don't have at the moment a lot of time, so I will come back, I think in some months when there's time again to continue the work. Everything I have shown you now is like on the GitHub repository. You can look it up yourself. And there is also a time-lapse video of the PCB design, so I really recommend to watch that. I talked about it, like I talk along the time-lapse video, so I think it's really interesting. Yeah, see you later. Bye.